You are welcome to Maths Messiah. In today's lesson, we are going to discuss the proofs in math methods. In math methods, we have a lot of proofs. So let's look at our first proof. Why is it that every number raised to the power 0 is equal to 1? So let us use numbers to prove. So this one we have a raised to the power 0 is equals to 1. Replacing a with a number, we can have 5 raised to the power 0 is equal to 1. Let us rewrite the 5 raised to the power 0 using the law of indices, that is the division between two numbers with the same base. Since we are using 5, we can say that 5 raised to the power 4 divided by 5 raised to the power 4 will give us 5 raised to the power 4 minus 4 will give us 5 raised to the power 0. So we can write 5 raised to the power 0 in this form. If that be the case, then it means that if we have 5 raised to the power 4 divided by 5 raised to the power 4, it can be written as 5 raised to the power 4 divided by 5 raised to the power 4 in this form. If we agree to this, then we can expand the numerator as 5 multiplying 5 multiplying 5 by 5. So we have 4 of it. Then we divide it by 5 by 5 by 5 by 5. And we have some cancellations. So each 5 at the top will cancel each one at the bottom. That is, the numerator and the denominators will cancel themselves. And the answer will be 1 divided by 1. And the final answer is 1. So we can say that if 5 raised to the power 4 divided by 5 raised to the power 4 is equal to 5 raised to the power 0, it's also the same as 1. So it means that 5 raised to the power 0 here is equal to 1. If you use any number, it will give you the same results. So every number divided by 0 is equal to 1. Let's go to our next proof. Why is it that any number, say a, raised to the power -1 is 1 divided by that number? So let us use 2 to form a pattern. We have 2 raised to the power 4. That one will be 2 by 2 by 2 by 2, which will give us 16. Then we have 2 raised to the power 3. So we reduce the powers. So reducing the powers, we had 4 here. So we reduce it to 3. So this one too, we have 2 by 2 by 2. And that one will give us 8. We have 2 raised to the power 2. And that one will be 2 by 2. And it will give us 4. We have 2 raised to the power 1. That one will give us 2. We have 2 by 0, 2 by 0. Let us pause here and come to our pattern. So you can see that from 16 we came to 8. Then from 8 we came to 4. From 4 we came to 2. This suggests that before we can get 8, we can have half of 16 will give us 8. Half of 8 will give us 4. And here too, half of 4 will give us 2. So this place, it suggests that half of 2 will give us what? 1. So let us continue our pattern. We have 2 raised to the power -1 because we are reducing our powers by 1. So -1, meaning that we need to find half of 1. Half of 1 is half. So that is why when we have 2 raised to the power -1, we have half. So in a simple case, when you have 3 raised to the power 1, it will give you 1/3. So this satisfies our proof over here. Let's go to our next proof. Why is it that when you multiply a negative number by a negative number, another negative number, you get a positive number? This is the reason why. When you have -3 multiplying 4, your answer will be -12. When you have -3 multiplying 3, your answer will be -9. So we are reducing the multiplicand over here. When you have -3 multiplying 2, your answer will be -6. When you have -3 multiplying 1, you get -3. When you have -3 multiplying 0, you have what? So here too, let us pause and go to our pattern. From -12, we came to -9. So meaning that when you add 3 to negative 12, it will give you negative 9. Likewise, when you add 3 to negative 9, it will bring you to negative 6. When you add 3 to negative 6, it will bring you to negative 3. When you add 3 to negative 3, then that one will also bring you to what? That is 0. That is 0. So let us continue with our pattern. So if you have negative 3 multiplying negative 1, then it means that we are going to add 3 to 0, and that one will give us what? 3. So we have our positive number now. That is why when you multiply a negative number by another negative number, you get a positive result. Now let us move on to our next proof. That is, when you have a number a divided by 0, we say that it is undefined. The result is undefined. Why? Why is it that every number divided by 0 is undefined? Let us investigate by using 8. So when you have 8 divided by 4, and we know that the answer will be what? 2. But we are not going according to that pattern. Our pattern will be like, let us have addition of 4 till we get 8. So we add 4 to 4 to get what? 8. So here we have 4 plus 4, and the answer will be what? 8. Our second pattern will be 8 divided by 2. This means that we are going to add 2's till we get 8. So we have our 2 plus 2 will give us 4, plus 2 will give us 6, plus 2 will give us 8. So it means that this and this, they are defined. Now let us move on to 8 divided by 1. So let us do the addition of 1 till we get 8. So 1 plus 1 will be 2, plus 1 will be 3, plus 1 is 4, plus 1 is 5, plus 1 is 6, plus 1 7, plus 1 give us what? 8. Now we move on to the final one, which is 8 divided by 0. So we are going to add zeros to get 8. And can adding zeros give you 8? So let us see. We have 0 plus 0 will be what? 0 plus 0 can't give you 8. 0 plus 0 is 0. You add another 0, it will give you 0. Add another 0, it will give you 0. So it will continue till infinity. So here we say that since we cannot continue adding zeros to get 8, it is undefined. The final number cannot what be attained, so it is undefined. I hope you get this one too. Now let us go to our final proof. Let us investigate to find out the reason why a raised to the power m multiplying a raised to the power n is equal to a raised to the power m plus n. Meaning that when you are given a number and it is raised to powers but with the same base, the powers over here should be added as we have here. So let us find out why. Replacing a with a number that is 2 raised to the power 3 multiplied by 2 raised to the power 2. Let us expand 2 raised to the power 3. So we have 2 multiplying 2 by 2. So we have this all multiplied by, then the 2 raised to the power 2 will give us 2 by 2. So this means that we have 2's multiplying themselves. So how many 2's do we have here? Let us count. 1, 2, 3, 4, 5. So in this way we can say that 2 is raised to the power 5. That is why a raised to the power m multiplying a raised to the power n is equal to a raised to the power m plus n, because 2 raised to the power 3 multiplying 2 raised to the power 2 can simply be written as 2 raised to the power 3 plus 2, and the answer will be 2 raised to the power 5. So this is the same as this. Then why is a raised to the power m divided by a raised to the power n is equal to a raised to the power m minus n? So in the same way, we replace it by a number. So let's take 2 raised to the power 5 divided by 2 raised to the power 3. So here too, we can write it as 2 raised to the power 5 divided by 2 raised to the power what? 3. And we can expand this by saying 2 by 2 by 2 by 2 by 2, because we have 5 of them. Then we divide it by 2 by 2 by 2. Then we can do a cancellation. This one takes away this one takes away this, and this one takes away this. So we have 2 multiplying 2, and this one can be written as 2 raised to the power 2. So in a simple term, we could have said that 2 raised to the power 5 divided by 2 raised to the power 3 is the same as 2 raised to the power 5 minus 3 is equal to 2 raised to the power 2, which is the same as this one. So these are the proofs in math methods. Please subscribe to this channel and you get more videos. Thank you very much for watching. Bye bye.